Dear students, you are told that hydrogen is a good reducing agent. But what is a reducing agent? To understand it, you must understand what is oxidation and what is reduction. Basic knowledge of oxidation they exist to human beings since very old days. They understood that when a substance combines with oxygen, then process is said to be oxidation. They also understood that burning of any substance is a process of oxidation. For example, when a fuel burns, like suppose methane burns, then it combines with oxygen to form oxides of its element carbon and hydrogen, CO2 plus H2. So it is an oxidation reaction. Similarly, burning of coal or any other fuel is also the process of oxidation. In both of these examples that are understood to be oxidation, heat and light is produced along with the oxidation reaction. But oxidation is not all about only burning reactions. There are other reactions as well which were understood to be or which are understood to be oxidation reaction. For example, rusting. Rusting of iron is an example of an oxidation reaction in which heat and light is not produced, or heat is produced but in very small amount and is not felt or understood by normal people. Iron combines with oxygen in presence of water vapor to form ferric oxide, and ferric oxide combines with water molecules to form rust. Similarly, all the rotting of fruits, vegetables, plants, or decomposition of dead bodies of living organisms are also example of oxygen, in which complex molecules combine with oxygen to become their oxides. So all these are examples of oxidation. By this, one thing is we know for sure that oxidation means combining with oxygen and forming compound called oxide of the substance which get oxidized. But oxidation is not all about combining with oxygen. There is one more thing, and that is separation or loss of hydrogen from a substance is also said to be oxidation. For example, Mg plus O2 giving 2 MgO is oxidation reaction. But H2S plus Cl2 to give 2HCl plus S is also an oxidation reaction. How? Because from hydrogen sulfide, hydrogen is removed and sulfur becomes free. It means it lost hydrogen to become sulfur. So the process of H2S to S is also an example of oxidation reaction. Loss of hydrogen is oxidation. Addition or combining with oxygen is also oxidation. But there are certain oxidation reactions in which neither oxygen is involved nor hydrogen is involved. Means neither combination of oxygen is taking place nor loss of hydrogen is taking place, yet they are oxidation reaction. How? That can be explained on the basis of loss and gain of electrons. Loss of electron by any substance is its oxidation. For example, look at this reaction only, 2 Mg plus O2. Here magnesium atom loses 2 electron and becomes Mg2 plus. So in this reaction magnesium is combined, but that we can understand with the help of oxygen as well. So there are certain reactions which are oxidation reaction, but yet oxygen and hydrogen are not, oxygen is neither added nor hydrogen is removed. Take example, you know about zinc plus copper sulfate. Then displacement reaction takes place. ZnSO4 plus Cu. Apparently in this neither oxygen is added or removed to any of the substance nor hydrogen. Yet here oxidation of zinc is taking place and reduction of copper is taking place. How? See, here Zn atom gives 2 electron and becomes Zn2 plus. So in this reaction zinc is oxidized to ZnSO4 or zinc is oxidized to Zn2 plus by giving 2 electron. So loss of electron is also considered to be oxidation. Let's compare. And what is reduction? Reduction is just opposite of oxidation. It means if oxidation is addition of oxygen, then reduction is loss of oxygen. Like let's have an example. Mercuric oxide, when heated strongly, then oxygen is separated from it and it turns to 2Hg plus O2. So in this reaction mercuric oxide is reduced to mercury. Mercuric oxide HgO is reduced to mercury because oxygen is separated from it, and reduction is opposite of oxidation. Addition of oxygen, oxidation, loss of oxygen, reduction. Similarly, we can come to another example as well. Another point means another definition of oxidation, that is loss of hydrogen. Loss of hydrogen is oxidation, so gain of hydrogen is reduction. For example, N2 plus 3H2 gives 2NH3. In this nitrogen combines with hydrogen, so nitrogen is reduced to ammonia. Nitrogen is reduced to ammonia. So this is a reduction reaction because hydrogen is added to a substance. Then we come to the theory of electrons. We take this previous example only once again. Zn plus S2SO4, ZnSO4 plus H2, previous example was not H2SO4, previous example was Zn plus COSO4. Though even this example could be taken. So it is ZnSO4 plus Cu. Now have a look at copper. I told you that Zn loses electron to become Zn plus plus, so it is oxidation of zinc. But at the same time copper, what happened to copper? Cu in CuSO4 is actually Cu plus 2. It takes 2 electrons and becomes Cu. It means change of Cu2 plus to Cu atom, means neutral copper atom, is example of a reduction reaction. So now we can differentiate between oxidation and reduction. Oxidation is addition of O2 and reduction is removal of O2. Then second is loss of hydrogen. Then this is gain of hydrogen. And third is loss of electron and here gain of electron. Let's see. Oxidation is a reaction in which either addition of oxygen takes place, or loss of hydrogen takes place, or loss of electron takes place. Whereas reduction is removal of or loss of oxygen, gain or addition of hydrogen, and gain or addition of electrons. Now what happens to those electrons? From where these electrons will come? Means if it loses electron, then there should be a gainer of electron as well. If hydrogen is lost, then where does its hydrogen goes? If addition of oxygen takes place, then from where does this oxygen comes? So I explain you this thing with the help of an example. But just one more quick revision. Oxidation is a process. Actually, to make it a little more elaborate, we can add a little more. Oxidation is addition of oxygen or any electronegative element, means non-metal, like addition of chlorine or addition of any other non-metal also can be, like sulfur, can be taken as oxidation. And loss of hydrogen or loss of any electropositive element means metal elements. What is similar between hydrogen and metal elements? That both of them give electron to become positive ion. And what is similar between non-metals and oxygen? That they gain electron to become negative radical. So oxidation is addition of oxygen or any electronegative element. If you find it difficult, you can ignore, but otherwise. And loss of hydrogen or any electropositive element. And you understand, electropositive element means metals and electronegative element means non-metal. Hydrogen is the only exception. And loss of electron, whereas reduction is removal of oxygen or a non-metal, gain of hydrogen or a metal, and gain of electron. Now let's discuss that a single oxidation or single reduction reaction doesn't take place. When a substance gets oxidized, then at the same time the another substance taking part in the reaction gets reduced. How? See, let's take example of H2 plus CuO. It converts into Cu plus H2. In this reaction, cupric oxide loses oxygen. So CuO to Cu is reduction. But another one, that is hydrogen, it gains oxygen and from hydrogen it becomes water. It means it is oxidized. So if you have a look at this reaction, hydrogen gains oxygen and is oxidized, copper loses oxygen and is reduced. What I am trying to say is that if something is lost, then there should be a gainer as well, then only chemical reaction takes place. Without it, a reaction will not happen. Like sodium will not be able to donate electron if there is not any substance like oxygen to gain electron to form it sodium oxide. Like see here, sodium plus oxygen, sodium oxides. In this reaction, sodium lost one electron and became Na1 plus. Whereas oxygen atom, both separately, oxygen atom gained 2 electron and became O minus 2. How? Because it combined with 2 Na. So, and only one oxygen atom. So if we balance it, then it will be 4 Na plus O2 gives 2 Na2O. So together 4 sodium atom gave 4 electrons and 2 oxygen atoms gained those 4 electrons, means per atom 2 electrons, and therefore it became O minus 2 over here in sodium oxide. In sodium oxide, you know, sodium is actually Na1 plus, and oxygen is actually O minus 2. And that's why their valencies are written opposite to each other. Oxygen's valency over here, sodium's valency over here. Because this is written because balance of number of electron given and taken takes place during an ionic reaction. So you understand that only oxidation or only reduction doesn't happen. At the same time, one substance when is getting oxidized, then other is reduced. I'll give you one more example, the same which we discussed before to understand better. Zn, I took this example, cupric oxide reduced to copper, whereas hydrogen oxidized to water. Now take this, Zn plus CuSO4, ZnSO4 plus Cu. Here, zinc oxidized to become ZnSO4, and copper sulfate, out of this copper reduced, you mean Cu plus 2 ions reduced to become copper. So some oxidation reaction can be explained with the help of oxygen or hydrogen. Some can be explained with the help of loss of electron or gain of electron. So we can define oxidation like this: a chemical reaction in which a substance either combines with oxygen or a non-metal, or loses hydrogen or electropositive element, or loses electron, is said to be oxidized. Reduction is just opposite. Reduction is a reaction in which a substance gains hydrogen or loses oxygen or gains electrons. If you find this oxygen or electronegative element, hydrogen or electropositive element a bit confusing, then you make it for three substances only. Gain of oxygen, loss of hydrogen, loss of electron is oxidation, and opposite means loss of oxygen, gain of hydrogen and gain of electron as reduction reaction. And one more thing, that single oxidation or single reduction doesn't take place. That's why we say it to be redox reaction. It means every oxidation reaction is actually not only oxidation reaction, it is reduction reaction. Same about reduction reaction. Reduction reactions are also oxidation reaction at the same time. Like I told you, Mg plus O2 MgO, in which magnesium is oxidized and oxygen is reduced. I'll take you one more example. FeCl2 plus Cl2 gives FeCl3. In this reaction, no oxygen or hydrogen is seen, yet it is a redox reaction. How? In this FeCl2 combines with chlorine. Chlorine is an electronegative element like oxygen. So when chlorine is added to FeCl2 to become FeCl3, then FeCl2 is oxidized. And chlorine combines with iron to become FeCl3. So chlorine is reduced. Now let's discuss is on the criteria of electron. See, iron is Fe2 plus over here. It gives one electron to become Fe plus 3 in ferric chloride. I hope now you understand that iron is ferric in this compound. So it is Fe plus 3. That is why this is ferric chloride and this is ferrous chloride. Fe plus 2 becomes Fe plus 3 by loss of electron, and Cl becomes Cl minus 1 due to gain of electron. So this chlorine has become Cl minus 1 with gain of electron, and this iron has become Fe plus 3 due to loss of electron. So iron is oxidized and chlorine is reduced. I hope you understood. In the next video, we will discuss about the term oxidizing and reducing agent as well.